Hello there. In this video we're going to solve this trigonometric inequality involving a tangent. So, as always, start with creating your graph. And you want to see multiple cycles, multiple periods for these kind of things to know when they repeat themselves and setting up that rule. Okay, so we got that, and what else are we going to need? It's a tangent ratio, so there are actually going to be various asymptotes involved. However, normally the asymptotes would be at negative pi over 2 and pi over 2, but this one's actually going to start at pi over 4. So I'll put some tick marks in here. And tangent of 0 is 0, so when x is pi over 4, this whole output's going to be 0. So we're going to have a dot here. And the period is, what is the period? Pi over 2, so we're actually going to have asymptotes here and at that negative 1/4 here. So normally this would go from here to here, going through that 0, but because we've shifted it all to the right by pi over 4, it's going to do this. So this location over here, this is actually at where pi is normally, so this is pi over 2. I'm moving backwards. When I put in pi over 2 here, I get pi over 2 minus pi over 4, that's pi over 4. And the tangent of pi over 4, the tangent of 45 degrees is 1. And we're multiplying that by 3. So that's actually going to get us up to a value of 3. But we won't stretch it too much, so we'll put in some dots there. Boom. And might as well get that one too. Yeah, I rethought that. I don't really want to stretch this one out. I want to graph what I'm used to graphing as a tangent function. So something like this, and then that's going to repeat again over here. So I'm going to wind up with these zeros that are always just a little bit in front of that pi. Boom, boom, boom. And then we'll have some more asymptotes too. We got those, and then we're coming in from the bottom. So I'm not paying so much attention to the y-axis right now. I'm more getting the form, then I'm going to worry about the y-axis later. Let's see, this one over here is going to have to go backwards. So I think it's right there. Bump. Something like that. Okay. So, and I want this whole thing to be less than pi or root 3. At this point, it is a little bit, I didn't mark where the scale was, but we kind of had this idea that this point here would be at that full elevation, normally 1, but actually it's up there at 3. At root 3, that's less, that's about 1.7, so I think it's going to be considerably less. So we'll draw that in right around here. So we see that it's actually pretty close to that value, the axis in there. So probably closer to it's on that left-hand side there, by that pi over 4 as opposed to pi over 2. But we'll trust the algebra to get us there. So now we got the graphing part. Now let's shade actually. So I want the curve to be underneath that line. So I'm thinking that that's this space, that space, this region. There's a whole bunch of regions. They all repeat themselves. I want to produce larger or smaller numbers on this left-hand side than that right-hand side. So clearly over here, curves above it, so that's not what I want. So I want here, 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 etc. All right, let's work the equation out and do the algebra. So we set them equal to each other because we're solving for where that intersection is, and then we're going to get that the tangent of this whole thing is root 3 over 3. And it's helpful to be familiar with your tangent ratios here, but the inverse tangent of that root 3 over 3, that's actually equal to, what is that one? That's that smaller of the 30, 60, 90. If you imagine This one over here, we want that to be like root 3, and this to be, that to be 3. Yeah. So that's 2 root 3. So there's our 30, 60, 90. Normally this is 1/2, and this is root 3 over 2. So you got 1/2 over root 3 over 2, which is 1 over root 3, which is root 3 over 3. Okay, so that is that 30 degrees, or pi over 6, right there. Now there's actually another one back here, but we're not going to worry about that because the period will get all of those for us. But that's going to tell us that x minus pi over 4 is equal to pi over 6. So now we can solve for what x is. Need a common denominator, so if I multiply these by 2, I can get up to 12. This by 3, I can also get up to 12. So I'm going to get 5 pi over 12. And if you look over here, that's actually going to be this location right there. That's going to be our 5 pi over 12. And it's a little bit less than that 1/2. There's pi over 2. So it's believable there. Right there, that is 5 pi over 12. And the region that we're interested in is it's going backwards all the way to there, and that was negative pi over 4. Now, this picks up again like here. That's 3 pi over 4. And this one over here, well, it's adding on that period. So whatever this is actually 5 pi over 12 plus pi, which I guess is 17 pi over 12. But we got this interval. Now, this is a little bit tricky here. These are vertical asymptotes, so they actually get open circles on them. You are not defined at that value. I'm going to go up there, open circle, onto that intersection, closed circle, open circle, closed circle, open circle, etc. So our final form, this is the union of all these different, because we're both here and here and here, all these intervals. This is going to be the union from negative infinity up to positive infinity. On the left-hand side, we have this open bracket, and we might as well start at that negative pi over 4 plus the period here from here to here. That is just pi. So we're going to do this as pi n, not 2 pi n, on up to, what do we want here? On up to 5 pi over 12 plus pi n. So the b value is 1 in this one, but as a tangent function, it actually repeats every pi instead of every 2 pi. And it's nice and symmetric. It just shifts itself over. There's not this up, down, up, down. That's why we don't have to worry about 2 different points where it's doing it. Okay, thanks for watching. Character and Scholarship for Life.